times the figure number. So here's how we can do it. If you're given the values or something, organizing them in a table is one way of organizing your information. So in figure 1, there were 5. You're going to write this down so you've got it. In figure 2, there were 9. Figure 3, there were 13. How many would be in figure 4? 16. So we're adding 4, 17. You want to change your answer? 13 plus 4 is 17. Very good. And then if I want to go back, I subtract 4. And I get the 1, which is really important. So describe the rule. It starts at 1 and goes up by 4. But really what we want to do to describe this one is the total number of blocks is 1, where it starts, which is how much there is in figure 0, plus the change, which is 4 times n. That's the rule. This is a huge part of this course, is developing that rule and using that rule. And this is what we're going to work on for the next little while in different ways. But that's what a rule looks like. So when we do a learning goal tomorrow, and you're asked to develop a rule, put your pencil down and watch. This is not what it means. Before we were describing the pattern with words, and you can still do that, but when it says rule, it means like an equation like this. This is what we're moving towards trying to do. If you can't do it, that's fine, but this is our goal, and I want everybody to understand what the goal is. And don't get confused by these variables. I just took them from here. T was the total number of blocks, N was the figure number. If you change those variables and got them wrong, that wouldn't be the end of the world. It's these numbers that are important. Where it starts and what's the change. And the change is being multiplied by the figure number. And where it starts is left alone. What if I did it, don't write this down. What if I did it the other way? T equals 4 plus 1n. Would that be okay if I got them backwards? Savannah, you say no, why not? Very good. I love that explanation. Jamarla, you want to add to it? Do you think that was a good explanation? So this red one starts at 4 and goes up by 1. That's a different relationship than starting at 1 and going up by 4. For the first figure, they would both be 5, but after that, they're going to be different. Justin? Yeah, exactly. The pattern would look different. So this one is not the same. We got to get the n multiplied by the right number, because that's what you're changing. That's how you think about it. N is the thing that's changing. How much is it changing by? It's changing by 4, so I multiply it by 4. Okay, now we're going to graph it. Do we have enough space here? Is this right? Yeah. Figure number 1 had 5. Figure number 2 had 9. Figure number 3 had 13. So plot those 3 points. Then I'm going to draw a line, and I want you to just watch me do it for a moment. Where does my line start? At 1, which is what we found in the table where the relationship starts. Okay, so put your pencil down and watch for a minute. This is 13. This is 9. What's the change from this point to this point? It's 4. What's the change from this point to this point? It's 4. A graph, this line is just showing the same pattern that was in the table, the same pattern from the blocks. If I go back 4 again, I get to 1. That's where it starts. So not only where the pattern starts, but we think about this as where the graph starts. When I hit this thick black line, that's where the graph starts. And that's the number that's part of our rule. Really, really important. And I can find the growth. We'll do this later on, but I can find the growth from the graph as well by looking at the change. Okay, let's take a look at the back. Each of the following tables shows a growth pattern. In each table, N represents a figure number, T represents total cubes, or squares, or Legos, or dots, or whatever you want to call them. Determine the rule for each table. Determine. How am I going to do this? What's required for finding the rules? Justin? You could. And in fact, that's not a bad idea, but I don't think we're going to take the time to do that. Maybe we'll do that for the next one. What else could we do? What did we do before? What is it going up by? How am I going to do that? Riley? So from 5 to 8, what's that? Up 3. From 8 to 11, it's up 3. From 11 to 14, up 3. And I hope you agree, we'll talk about this later, but if that changed, if it was like 3, 3, then 5, something weird's going on. What it's changing by can't change. I mean, that can happen, but not yet. Okay? Okay, good? So now what do I do? Remember, this is our goal. What's the change and where does it start? Ronnie? So plus 3. N. The change gets multiplied by n. That just came from there. And what do I start at? 5. Where did you get that? From figure 0, which was given in the table. So every time we do this, it's going to be t equals blank plus blank n. And we fill in those blanks like that. But remember where all this came from. Building the blocks, thinking about the growth, and then thinking about what else you have to add. Okay, I want you to try this one. Okay, most people have found, at least most people on that side of the room that I went over and looked at, found that this is going up by 5. Do you agree? So t equals something plus 5n. Or I can write those in a different order. They don't have to be in this order. So sometimes we write it the other way. 5n, that's the change, so I multiply by n, plus something, and a lot of people did this. Tell me what my mistake is. Ashton? Be careful. 4 is the first row of the table, but it's not figure 0, and it has to be figure 0. So if I want to go back to figure 0, what do I have to do? Subtract 5. What's 4 minus 5? Negative 1. So minus 1. What would that look like? If it was like this. So the first one has 4, and then I subtract 5? It wouldn't work. So when you're talking about blocks, those negative, and we won't see negative numbers like that too often. When you're talking blocks, it might not make sense, but in other situations, it does. Okay, good. And if you haven't already, try the next one and do the same thing. Be careful. Brandy, what did you find this changing by? No, the change? 2. Everybody agree? Up 2. 3 to 5 is a change of 2. How would I figure that out if the numbers were bigger? Subtract 5 minus 3. Right? What happens here? Uh-oh. What happens here? So when that happens, I'm surprised that example shouldn't maybe be here just yet, because we're going to talk about what to do when that happens, but we're not going to do that yet. So for now, that means it's not a straight line. It's not like you could build it with blocks. You still could. But it's a different kind of thing that's happening there. Okay, here's what I want you to do. I want you to, I'm going to hand out the practice.